So in FHIR, the purpose is that people can send using Restful instructions, can send a query to retrieve resources from a server application. But this will be something that we will have a look at later. Also to post resources so that they can be handled by the server application. In our case, the server application will be your local OpenClinic server. And we will do some testing with a client application, but it will be quite a stupid client application. It will be a browser. So we will just use a browser and we will type in the RESTful commands manually for retrieving resources from OpenClinic.
Okay.
Because this is the first need that we have with remote applications. These applications want to retrieve information from OpenClinic.
So we get operation. Right. Where we get operation.
Yeah. With a get or with a, well, it's we will see. We have different instructions that we can give in these RESTful implementation of HAPI, and for there's in fact there's two kinds of get operations, and there's I think three types of put operations or post operations.
Okay.
In fact, when OpenClinic starts, it will automatically start up a server, which is in fact a servlet, that is going to listen for requests, for queries that are coming from outside, that are coming from clients. And this server, you can find it in BE, HAPI, RESTful Servlet. So this is in fact where things are being initiated, and there's not a lot in there. In fact, what it will do is instantiate a server according to a model that is coming from the FHIR library. And in this library, you can specify the version, the FHIR version that you want to be compatible with. So we have selected here the version R4, which is not the latest version, because in the meantime, we are already in version R5, and FHIR is quite a young standard. It is a little bit dynamic, and so new things get added. I will not say every day, but at least every month there's new stuff coming up. So we are using this version R4, which is a very commonly used version in health informatics. This thing here is not very important. In fact, it is a header that will be shown each time that we will send a request, and if that request is being sent by a browser. So in our response, we will send some nice information whenever a browser is requesting an HTML representation of the resources that are being returned by the FHIR server. Because in fact, a client that is sending a query to our FHIR server can specify the format in which it wants to see the results. And typically this format can be XML or can be JSON, one of both. But in the HAPI implementation, we can also ask for an XML HTML or a JSON HTML response. It means that the XML file or the JSON file will be wrapped into HTML code so that it can be read easily and nicely in a web browser. So for debugging purposes and testing purposes, that is really magnificent, because otherwise you always have to look at the raw JSON or XML code.
Okay, I see.
And if we are requesting the XML HTML or JSON HTML format, the HAPI server will automatically add this powered by header. And so this will be put on top of the response. Yeah.
Okay.
But that is not very important. The most important thing is here the initialization. And because we have a default implementation of a Restful server, but that is quite a dummy server. It is just providing the basic functionality for accepting a RESTful query and for sending a response, but it has no knowledge about the resources that can be served, about the types of queries that can be received. Okay. So if we want to configure our HAPI FHIR server, we will have to specify, first of all, the types of resources that it will be able to serve. And in fact, we are not really specifying exactly the types of resources, but we are specifying a list of resource providers. We are going to program a series of classes that are capable of providing resources of a specific type. For instance, I have here in our existing, which is still very limited, limited implementation, I have a resource provider for a patient resource. So I can send back a patient resource with this provider. This provider will encapsulate the code for receiving queries from a client, and will have the code also to respond to these queries by sending back a set of resources of a specific type. And here, these would be resources of the type patient. We will see where it is specified afterwards. Yeah.
Okay.
I have also a second resource provider here, which is a resource provider for imaging studies. So this is a resource provider that will be capable of responding to queries for medical images, and will then be able to send back digital images in a format that we can just define. Typically, this can be a DICOM format.
Okay.
And when we have made a list of our resource providers, we first create here an empty list, an empty array list. Yeah. And to that array list, we are adding systematically new resource providers. And when we have added everything, then we are going to put this list of resource providers in our servlet, in our RESTful servlet.
Okay.
Then this empty HAPI server will already have some content. It will have a list of resource providers. And these resource providers will know what to do with specific queries for resources.
Okay.
And then we have two other types of pieces of code that we can use for our server. The first one, these two are interceptors. And these interceptors are in fact, this is code that will be run by the HAPI server before serving a query. And so here we see that there is a response highlights interceptor. What does it mean? This is the part that will check the format that has been requested by the client. And when that format is JSON HTML or XML HTML, it will transform the resources to be sent back Before sending them, it will transform them into HTML format and with a nice colored presentation. There's also another interceptor that will always check if the user that is requesting a resource or is sending a resource has the necessary authorization.
Okay.
This is still very low level. We only check if the user has API rights, and if the user has rights on the API, for the time being, the user can do everything with the API, everything that has been foreseen. So it's not very granular, and level of granularity, we will see. Maybe if we move forward quickly in the next, let's say 10 days, then maybe we can also take care of some of those authorizations. If not, then it's not really a big issue. The content is more important for me. Okay, so then we can have a look at, that is always interesting to understand this type of code, is to have a look at a couple of examples. So you can see that basically once we have this authorization interceptor, then yeah, it will be the same one for all the resources. And it's just checking if this is an authorized user. You can have a quick look at it. Here we have the OpenClinic Authorization Interceptor. If we open it, then what we'll see here is, first of all, we will check if there is a parameter in OpenClinic that is called enable FHIR authentication. Yeah. So this is a configuration value. The default value is 1. It means that FHIR authentication is enabled. But if I would have disabled it by putting a value 0, then automatically the system will say, okay, it is allowed to use this interface. So I can just switch off this, this parameter, and there will be no authentication needed anymore.
Okay. Okay.
But normally this parameter will not have been specified in your OpenClinic instance. So it means that the system will use the default value, and it means that it is enabled. So then it will go further here. So it will look at an authorization header. And if there is no authorization header in the message, then in fact, it will say that there is a missing authorization or an invalid authorization. It could be something wrong with the header. And if it throws an authentication exception, then typically the client receiving that authentication exception will have to do something with it. If it is just an application, a client application, and which is a machine application, then it will handle that error and probably log an error somewhere, or maybe send a message to a system administrator. If it is a browser, the browser will handle this authentication exception by requesting for a login and a password, so that it can construct an authorization header and add it to the request.
Okay.
So that is what happened when I connected on your computer. Yeah, then it asks for a login and a password because it sees that there is no authorization header.
Okay. Yeah.
If we have a header, then it will do some decoding, because typically these headers are base 64 encoded. So we have to decode it, we have to extract the user, and then the system will validate if this user is existing, if this is an existing user in the system. If this doesn't return a valid user ID, so yeah, first it tries it to recognize it as an alias. If it doesn't recognize it as an alias, it's gonna search for the number 4. So an alias would typically be admin, the login admin would be an alias. but the alias admin is being linked to a user ID, which is number 4. So I could have used admin or 4 for logging in to the API. Because,
okay, perfect.
so if it doesn't work with the alias, it will try to do it with, it will try to find, let me see.
Wait for.
I have the username too, if it is. Yeah, it will try to make a user ID. So if it is an alias, it will translate the admin into user ID number 4.
Okay.
If it doesn't find the number 4, because if I put number 4 here, it will not, this is not an alias, it will not return a user ID. It will just consider the login as a user ID. Yeah. If I would specify an alias that doesn't exist and which is not a valid user ID neither, then it will also generate an error and saying, okay, there's a missing or invalid authorization header. If I get a user ID, which will be 4 in my case here, then we will also extract the password from the header. And then the password will be encrypted, because it needs to be encrypted for checking authorizations. And then we are going to validate if the user ID that is being provided and the encrypted password, if this is a valid pair for a user. And if it is, then I have my user that is connected to the system.
Okay.
And I will then check if this user has is authorized to use with the system, so it has not been deactivated. This is here, user has permission, because you can also deactivate the user. If it is an active user, then I will check if this user has an access right, which is called MPI API select. Yeah. If it has this access right, it will in fact say that this user is allowed to do all operations on the API. And here we could be a little bit more granular. I could add more access rights here, more specific access rights, for instance, only on patient objects, only on lab objects, only on imaging objects, and so on. But for the time being, we will just allow everything. Yeah.
Okay.
So maybe to show you the link with the OpenClinic application where we can specify this stuff, I will show that here. Okay. So well, this is a user. So the first thing to know if a user is
has a permission.
Has a permission and has an alias too. Yeah. So the alias of the user is being specified here, this one. Yeah. That's the alias. I can see that here in my computer, the user ID is number 4. Yeah. This is the basic administrator account with an alias. And here it has not been stopped. So if I would check stop here, it would not have permission. Yeah.
Okay, I see.
So it is also using a user profile, which is called system administrator. Yeah. And it is also, because this is just the name of a profile, a user profile. Yeah. And this is also a logical system administrator. This is not just a profile, but it is a specific marking to say that this is system administrator. As soon as I check this, it means that this account will have access by default to almost all access rights. There's some access rights that are being excluded, but there's very few. But the user will have access to the API. If it is not a system administrator, I can specify access in the user profile that is being used here. So where do I do that? I go into permissos. Oh, well, let me maybe put it in English. It will be better.
Oh, I can understand more or less.
Yeah, but I think it's going to be better if I put it in English.
Up to you, I mean. Okay.
Language. Let me just change the basic parameters here. We'll put Belgium. So and I have this one. I will change the language of the user. That's done here. Oh yeah, French, English. Any preference, French or English?
English.
Okay. Right, so now it should be in English. Yes, okay. So I can have here a look at these. So if I have a user records, permissions, we can have a look at the user profiles. And in fact, in these user profiles, if I select one like system administrator, I will have a look here, control of MPI. Yeah, I see here that I have a KHIN section, which is in fact for the setting up regional networks. And there is an access right, which is called MPI.API. Yeah. So this is giving access to the API. And if I click on view, it will add a .select access. This will be .add, .update, .delete. But I only need, in fact, to be able to work with the API. It's enough to have this select value. So it means that I have access to the API. But in my case, I don't need it because my user account has been marked as being a system administrator. And so I automatically get all these rights.
Okay.
That's sufficiently clear? Yeah?
Yes, yes.
So another example that we will have a look at are these resource providers. And so we will have a quick look at the patient, the Restful patient resource provider. So you should have that on your machine too. And here we will see that there is different types of operations, and they are being marked by annotations. The first one is this override. This means that in this annotation, we will specify, this is not neat, it should be like this. We will specify the resource type that is being served by this resource provider. So in the interface resource provider, which is a Java interface, there is a standard implementation that will that enforces us to have a method which is called getResourceType, so that the happy server can easily request or can easily investigate what type of FHIR resource is being served by this resource provider. And we just return the class of the resource that we are going to serve with this resource provider.
Okay.
This is a patient. And so this patient class is, this is in fact the patient class from the HL7 FHIR model. So
Okay.
this is a model that is being provided by the happy implementation. So I didn't program that myself. So this patient model is being provided by happy.
Yes.
Then it's not important if you leave this brackets out, tend to remove them, in fact. So we also have what we call a read annotation or a read operation. This is, in fact, the code that we are going to use when a user is requesting for a specific resource with a single unique ID.
Okay.
So each resource has an ID, and so we see that the parameter here will be the ID. And then based on that ID, we will search for a resource that we can send back based on that ID.
Okay.
I will show you how that works in, let's see, can I hide this stuff here somewhere?
Yes, I saw some examples of this. I can follow you because it keeps reminding me things that I read.
Yeah.
So.
Just a moment, because I'm trying to. I don't know why this is not working like this. Okay. I think I should be able to get rid of this this header, but no, I don't. It's getting in my way. So if I'm requesting FHIR, and I would say a patient resource, and I'm going to give an ID number of that resource, like 9966. This would automatically translate, in fact, into a FHIR read instruction. Okay. Because after this FHIR instruction, I have specified patient, and I will show you where that comes from. The happy FHIR server will know that it has to look for a resource provider that can serve a patient resource. Yeah. And I only have one resource provider. So in fact, it is going to run through the full list here of resource providers that have been added. And for on each of these resource providers, it will execute the get resource type method. Okay. And this will return the resource type that is being served by that resource provider. As soon as it finds one that is serving patient resource, then it will run the read operation on this resource provider. And then this resource provider will pick the ID. An ID, and you may have seen that in FHIR, is composed of different parts. It's an ID system, and then you have also the ID value, and you can also have some comments, and you can have a display value, etc. The only thing that we are interested in here is the ID part, so the number, the ID number. If it is, in fact, we are converting it from a UUID. This is not very important because this is being used in a master patient index server. And so there we get a unique ID, which is composed of letters and figures. And it has to be converted to an integer, to a local unique ID. If we cannot convert it because it's not alphanumeric, then we will have a return value of -1. If it is a return value of -1, it means that it's not an alphanumeric identifier, and we will just look for the person that is identified by that identification number. If the person that is being returned is valid, then we will execute a function on that person object, on this admin person class, which is called getFHIRPatient. And this is, in fact, the function that will transform an OpenClinic object, which is a person, administrative person, will
Yes.
transform that object into a FHIR object, a FHIR patient resource. It will fill up a new patient resource with the content of the OpenClinic object and then send that back. And when we return this, it means that we have a patient, a happy FHIR patient resource that we are sending back, which is just a class. And then the happy FHIR server will take care of converting that class into a RESTful response in the requested format, be it XML or JSON. Yeah. So we don't have to take care of that. So that is being handled by happy FHIR. So this was the second type of operation. The read operation is just retrieving one single resource with a unique identifier. Okay. We can also search for resources. And in fact, these names here are not very relevant. So I can give a method name here as I like. It's not very important, in fact, what type of method name I will give here. I can just invent something if I want to. So here I have invented something like find patients. But because I have put this annotation here, search, it will be a method that will be mapped onto the search methods of the happy library. Okay. And so I can specify here the different parameters that can be received by this function or by this method. Yeah. And I can have different predefined. In fact, these can be just strings. These are just strings, but the happy FHIR model already has some predefined strings, like for an identifier, a gender, birth date, family, given, telecom, email. But I can also add other parameters, and if they have not been standardized by a happy FHIR standard, then, or by the HL7 FHIR standard, then I can just invent them myself. That's really not a problem. It has to end with two parameters, which is the HTTP request and the HTTP response, which are in fact handles to the request that we have received and to the response that we are going to send back to the client. Yeah. So these ones are in fact mandatory. And in this method, what I'm doing here, just an example, is first I define that I will return a list of objects, patient objects. So and of the type FHIR patient. So these will be a list of resources depending on the query or the parameters that I have sent here in my query. And so this is in fact, I start with an empty list or an empty vector of patient objects. And then I will use these parameters to figure out which are the patients that would match the combination of parameters. Okay. So I'm executing here a function search patient based on the parameters that have been passed on. Yeah. Okay. And I will then receive, in fact, a result, which is, let me see. What type of result do we get here? Search patients. Did I put that? Search patient in MPI. Oh yeah. So it's a function that was specified somewhere else in BE OpenClinic MPI. I have a class here which is called search patient, and that will, based on the parameters that I have, this one here, yeah, it will fill in all these parameters and then execute on that submitted here, search probabilistic. Yeah. And so with these parameters, something like search probabilistic. Where is it?
I saw it up.
Yeah.
No, a little bit down maybe. I lost it now, but I saw. I think I saw it somewhere. Okay.
Let me see. We'll find it somewhere.
Okay, here. Mm-hmm.
Where?
I think. Oh no, it's no. I thought it was the definition.
Yeah. Will be here somewhere, but okay, let me find it. Search probabilistic. Yeah, this one here.
Yes. Okay. Okay.
So this is the function that will, in fact, look for all these patients, and then it will create a list of patients with this, which is in fact a sorted map. So this is one of the list types that we can. It's not really a list; it's a map or a hash table that we are going to return. And so we receive this sorted map of patients. We will run through these patients, and for each patient there, we will in fact transform the patient object, the OpenClinic patient object, into the FHIR resource and add that to the list of patients. So it means that I will end up with a list of patient resources that have been retrieved, and then I will just return that list of patient resources.
Okay, so it's like the list of patients which are born in this day.
Yeah,
and,
yeah.
Okay.
Indeed. So I could have something like, we'll do the same here. In that case, if I want to request or I want to go for the search, I don't use the same syntax here. I'm going to specify, in fact, the parameters that I want to use. And so if I say family, and I will use here DE, I don't know if there's many of them, but could be. Enter.
We don't have to specify like search, like the verbs.
No, because you have here this question mark. So this means that you're specifying a set of parameters.
Okay.
And then it will automatically go to the search section of these resource provider. And so if I look now in the results, I will see that I have a whole list of patient objects. So I will take the first one here. The family name, starts with DE, De Acosta. And then I have another one, Beasis, etc. So I have a whole list of objects, patient objects, that have been created. And each of these patient objects has some content which is specified according to the FHIR standard. Okay. You can have an ID number or language. We have identifiers that are being provided by OpenClinic, name, family name. Sometimes we have these contact data or telecom data, gender data. And this can be extended, but for our purpose, where we needed this until now, for a master patient index, this was sufficient. So we didn't need administrative information or so.
And can we display in another format directly from the browser?
Yeah, sure. So here, this is the header, in fact, that is being added, where when I said it, that it had to add a powered by header. This is, in fact, the powered by header, this part. And this allows you to select here. So it's going to automatically add a parameter. You will see that. Suppose that I don't want to see it here. Now it's in JSON. JSON, this is HTML JSON. But that's the default. I can also ask to have it in HTML XML, for instance. If I click on this, you will see that it will execute the same query. But it has added here another parameter, which is format. So format HTML XML. It's not in the search method that I have defined, but it's one of the default parameters that can be understood by the happy FHIR server implementation.
Okay.
And so here it has transformed everything in XML format now.
Okay.
Yeah. And if I would like to have the raw data, I could just click here on raw JSON, and it will again do the same and serve me a list of, yeah, and then I have the raw JSON format, and I can also have the raw XML format.
Okay.
Of course, this is a little bit less readable than an HTML format. So far, so good?
Yes, yes.
Okay. All right, so that was the find. And then we have some other methods. We will not start to implement them today. We can see where we get, maybe afterwards. But this is for updating. This means that instead of having an external application requesting for a patient resource, it would allow an external application to send a patient resource, and an update means that the patient resource already has a unique ID, yeah, already exists in the server database, and that we are going to update information of that resource with information that we received from the client.
Okay.
And so it means that I have the patient ID. This is the resource that I get. I will first verify that really this patient is existing. So what I first do, I take this, the FHIR patient object that I received, because I'm receiving an HL7 FHIR patient object, and I'm going to use a function here on my admin person to transform that FHIR object into an OpenClinic person object. Yeah.
Okay.
And so then I can start working with it. I'm going to check if really this patient already exists. If the patient does not exist, I'm going to find an alternate identifier, because a patient object can have different identifiers, and I can use one of the other identifiers to see if I can have an exact match with the patient. In the end, if the patient exists, then I'm going to update the record. This implementation, if the patient doesn't exist, we create a new record. This is implementation. So if I would say, no, if the patient doesn't exist, I refuse to do anything, I can also generate an exception here.
Okay.
But yeah, this has the advantage that you only have to use one method, which is the update method. And for a non-existing patient, you're just going to insert it. And so you don't need different methods for updating and creating new patients. But I can also have a create method, which will only receive a patient object. The first one with update would also receive an ID. Yeah? But if the ID doesn't exist, yeah, then it will automatically create here in this case. But if I create, I know that I don't have to update. I will just create a new patient object. I will not even verify. Well, I should not even have to verify, but to be sure that people are not creating double entries, I still try to check if the ID of the patient object already exists or not. And if it exists, then we will send here an exception.
Okay.
Possible entity exception, and saying, yeah, the patient already exists, so you cannot create it again.
Okay.
For instance, if there's no identifiers that have been provided, we can generate another exception where we say, yeah, at least one identifier must be provided. If some mandatory data is missing, we can also generate an exception. We need at least a family name or the given name. of the patient.
Okay.
And in the end, in fact, if we don't have any errors that have been detected, we will try to store the patient. And in the patient, yeah, that's an interesting one. So why do I have to load it again here? Oh yeah, this is the first place. So I don't have any errors. It means that I can load the patient from the FHIR object. And then we can also extract the picture of the patient. So the FHIR standard also allows for transferring JPEG or bitmap or any other imaging formats between the client and the server.
Oh.
And so we extract that and we also store the picture. And then we have created a new patient. Then there is another method, but I haven't implemented and I don't think I will ever implement it. It's allowing an external application to delete resources from the server. But we never delete anything in OpenClinic. So, and I definitely don't want to delegate that to external applications. If we can hide or delete something, it would have to be done from within OpenClinic.
Okay.
Okay, this is just a utility function. It's not important. We don't even need it in that. So you see that we have these operators, which is, well, the override is used by the Happy Server implementation to know which kind of resource is being handled by this resource provider. And then from the client, we can receive a read instruction, unique object ID, a search instruction to find a list of resources, the update instruction to update an existing resource, and a create an instruction to create a new resource. And then the destroy, but we are not going to implement that. So this is a little bit the logic. Now, how can we make sure that all of this is being started up by OpenClinic, and that OpenClinic will know what to do when what kind of code to use when I'm specifying, for instance, a URL like localhost OpenClinic FHIR, because it will receive this FHIR stuff. And maybe if you have already looked here in my directory here, in my folders, my web folder, there is no FHIR. I don't have a FHIR folder there. So it means, yeah, how can the system know what to execute? This is specified in a file, and this is typical for Tomcat. So this is Tomcat, Apache Tomcat specification. You have in this webinf folder, you have a file which is called web.xml. Yeah.
Okay.
And in this file, web.xml, there's a set of definitions, but we will not run through everything here. Well, maybe one. We will see here that we have specified a couple of security constraints. So it means that when we are using a URL pattern that starts with FHIR, for both methods, the get and the post method, it means that I want to make sure that I have to check that this user, the user that is requesting this, is a FHIR user. So it has the role name FHIR user.
Okay.
And in fact, this is being handled by a method that is specified in the OpenClinic, in the Tomcat configuration. So where does the Tomcat find that the actually connected user is a FHIR user? There's two possibilities. The basic possibility is that And we will have to see here in our local implementation of Tomcat that here in the configuration, you have a file that is called Tomcat users. Yeah.
Okay.
And I could have defined here in these Tomcat users something like, so here I have a, sorry, it's a little bit difficult to read, but I have a list of users, and one of the users here, this one is a user with the role manager GUI. I could have defined here a user with the role FHIR user. Yeah. But of course that would be static. I would have a username and a password for that single FHIR user. And yeah, anyone that has that login and password would be that single FHIR user. And I would not be able to know which specific user it is, because if I have 10 users that need to have access to the API, they would all use the same user account. So that's not practical.
Okay, I see.
So what I have done is, in fact, to write a class, and we will find that here in server XML. Maybe I should open it with a proper editor. Is it not too small? Can you read it?
No, yes, I can read it.
Okay. We will see that we have, yeah. So here at OpenClinic Realm, yeah, I think that this is the one. So here we have a class that is going to be used for for users, for identifying users. So I'm not using the user database. By default, it would use the user database, which is in Tomcat users. But I have modified here the class name. We are not using the user database of OpenClinic, of Tomcat, but we are using an OpenClinic class to verify if a user is a FHIR user or not. And in fact, with the login and the password that we are providing, the system will be able to verify if it is a FHIR user. It will not look in the Tomcat users database, but as we have specified, it will look it will use this class here, search a source BE happy here, OpenClinic Authorization Interceptor. And so it will use this class to check if a user is allowed to access the interface or not. And this will return the authorizations, yes or no. So it doesn't come from that single file, but now it comes from the OpenClinic database.
Okay.
And that's also because this class is only has to be available before loading any of the applications. And that is the reason why when we installed the Tomcat server, that we have also in the libraries of Tomcat, you may have noticed that we had, in fact, our MySQL connector and Primrose for the databases, but we also had an archive, which is OpenClinic Realm. And so this is, in fact, a library which is only containing that code for checking if the OpenClinic user is a FHIR user or not. So it's
when you say if it's a FHIR user, you mean the format of the object? I mean, if it is a user which has the specification of FHIR, like the format that FHIR specifies?
Well, it's FHIR user is just an attribute that is being added to a user. Yeah, and in fact, this attribute is being checked here in Web XML. So a user, before getting access to any resource that starts with FHIR, a URL that starts with FHIR, this user needs to be a FHIR user. So it's just a label. I could call it anything. But
Okay.
it will check with that OpenClinic Realm functionality if the connected user is a FHIR user. And if the user that is connected has the MPI API select right, then it will be returned as a FHIR user. And so we will know that it can access this kind of URL.
Okay, I see.
Yeah. In fact, it will, once we know that we can access this URL, we still don't know where we have to look for the code for anything that starts with FHIR. And that is configured a little bit further here. So we will see here in the servlet, there's a servlet that has been defined, and there is a servlet mapping. The servlet mapping will tell me that everything that starts with FHIR will just be sent to a servlet that is called FHIR servlet. Yeah? But it's just a name. And so if I want to know which is this FHIR servlet, I will have to look at the servlet definitions. And I have one servlet here that is called FHIR servlet, and it maps onto the servlet class BE happy RESTful servlet. And this is the class that I have. Yeah? So it means that everything that starts with FHIR here will be sent to to RESTful servlet Java.
Okay.
After having been authentified. And once I get here in the RESTful servlet Java, it will look if it has to initialize the servlet. Once the servlet has been initialized, it will have added also all these resource providers, and it will then process the URL. And it will in fact only process the part that is coming after the URL pattern. So it will process patient or image study or something like that. Yeah.
Okay, I see.
This part here is being stripped off automatically, in fact.
Okay.
And so everything that starts with FHIR is sent to that servlet, and I don't need to specify any GSP code or whatsoever.
Okay.
Good. That being said, we now know that we could in fact create a resource provider for any kind of resource that is being served by or that is being defined in the HL7 FHIR standard. Because any of these resources should also be implemented in Happy FHIR. And so when I receive a query for a specific resource, the only thing I have to do is to check if it is a read query, meaning that I have to retrieve one specific resource, or if it is a search query. And then it means that I have to look for a list of resources and return that list of resources. So I will then instantiate for a read operation. I will just transform internal OpenClinic data into an HL7 resource. For the find operation or the search operation, I will create a list of resources. It will be empty in the beginning, and then I will fill it up with all resources, OpenClinic resources that are matching the search criteria. And of course, these OpenClinic resources will be transformed into HL7 FHIR resources. So this part is really not difficult. The tricky thing will be to transform OpenClinic content into a FHIR resource.
Okay.
Because for sure, there's never a one-to-one mapping between an OpenClinic object and a FHIR resource. It means that in order to compose a FHIR resource, we will have to search for pieces of the information in different OpenClinic objects, bring them together according to the FHIR logic, because the FHIR standard, it has been built around an object model that is one of the possible representations of a medical record or of a patient record. In OpenClinic, we are using another model, so we will have to transform or translate our OpenClinic model into this HL7 FHIR model. The same when we receive an update or a create request, we will have to first transform that FHIR resource into a set of objects, OpenClinic objects, that we can handle internally and that we can save. So the complicated part is this translation part. And so I will let you do some translation. If it works, we will see how far we can get for one or more objects or one or more resources. But we will first start with the skeleton. You will see that you have I have provided some kind of an empty base class, which is called Restful Resource Provider Empty Base Class. And this is some kind of a skeleton for a resource provider. So if you open that one, you will see there's not a lot. We have this override, and it can serve some kind of a class, some kind of a resource, an HL7 FHIR resource. We will see which one we need. By default, I have put here service request, but it could be anything. We have the read operation, which will just retrieve, and I want to give you an example for lab orders, so I already put some comments there, but so we will retrieve a lab order from OpenClinic. And here we have a search where we have the possibility of searching lab orders. I would have the possibility here of searching lab orders for a specific person between 2 days. So these would be my parameters. If I need to, I could add other parameters later if I like. And then we have the update, create, and destroy methods, but these ones are, for the time being, they are empty. Yeah.
Okay. So before we have seen this page for patient, and now we want to create the same page for other resources.
Yeah. And so that is what I want to do this morning. I will create a new resource provider, and this time for a lab order. Yeah. So for the lab order resource. And based on that model, you will then have the possibility of creating your own resource providers for other objects. And yeah, it sounds simple, but you will see that it requests some sweating and some. You have to overcome a few issues because one of the issues that you will have is that for the time being you don't have deep knowledge of the OpenClinic object model and probably not don't have deep knowledge of the FHIR object model neither. So you will have to search for some of that information. And to be honest, I don't have deep knowledge of the HL7 FHIR standard neither. So I also always have to look up stuff to know how it works. So it's new in OpenClinic to serve these objects. Okay, so what we are going to do, we are going to create a new resource provider. How are we going to do that? I'm going to copy paste this one. So I can do copy here, and then in my happy, I will paste, and yeah, I have to close it. And normally it will suggest me a new name. Yeah, I will call it not empty base class, but provider. Let's call it Restful lab order resource provider, something like that. Yeah. So now I have an empty Restful lab resource or lab order resource provider with exactly the same content as the empty class. Yeah. The first thing that you will have to know is what kind of HL7 object you are going to, or HL7 resource you are going to serve here. And this is not so easy to know. In fact, related to lab data, you have basically two major options. An order form is basically some type of a service request. You are requesting from the lab to provide a specific health service. Yeah. And in HL7, in the HL7 FHIR standard, there exists something like a service request resource. And this service request resource will contain the content that might be interesting for us. So if we have a look here on the internet, yeah, I had the standard open somewhere. This is observation. Yeah. Let's see. It will be service requests. Yeah. So in the HL7 FHIR standard, you have a resource which is called service request. And then you can do some reading here, but typically this is a resource that has been developed by the Orders and Observations working group. For diagnostic tests, you have, in fact, two types of operations. You have an order, so which is a prescription, could be for lab exams, could be for a procedure, could be imaging, whatever. This is an order, and this is what we call a service request. And you also have what we call the results of that diagnostic test, and this is called the observations. And that can be something like a report or a diagnostic report. That would be the information that is being returned by the health system according to an order that had been sent previously. So this order form will, in the version 4, R4 of the FHIR standard, will be a service request resource. And in the documentation, you can see that this is some explanation, and you have examples like diagnostic tests, biopsies, therapies that have to be ordered, surgical procedures, etc. You have all kinds of things that you can order, in fact.
Okay.
And then if you go a bit lower here, you will see what is the structure of such such a resource. Normally, a resource or a service request will have a unique identifier. This is how you can identify uniquely your service request at the level of your clinical database. So each resource should be uniquely identifiable. Otherwise, it will not work. And if you don't have a unique ID in your database, then you will have to invent one, because it's a mandatory element normally.
But is that for a particular instance of the resource, or for the resource in general? We need
no, for the particular instance. Each instance of the resource class needs to have its own unique ID. For instance, for a patient, it will be a unique ID number, patient ID number. But for a lab order, each lab order should also have a unique order number.
I see.
And this is not so difficult to understand. In fact, if you have a look at the results that we obtain here, I had here a list of different like patients. Yeah. Each patient automatically is being represented by such a unique ID. Yeah.
Yes.
And this is generated automatically, because I have specified the ID for the patient. FHIR standards or the Happy FHIR library will automatically add this full URL. And it means that a client, if I'm using a browser, I can just click on it, but a machine could then just execute that or send a RESTful request with this URL, and then we would automatically get the content matching that object. And so I need a unique identifier to be able to retrieve that specific patient object.
Okay.
All right. Where was I? There. And so then we see a lot of stuff here. And if I must admit that also for me, some of these labels that they have put on these properties, and I don't always understand it. And sometimes it's clear, like the status of your request, service request. Identifier is intent. Is it an order, or is it a work plan, a proposal, whatever? So these are things that you can specify, of course, that you can understand. The priority is easy to understand. But then something like, let's say, even order detail. What do they mean with by order detail? So I can then click on this, and it will explain me a little bit what is the purpose of this this element, of this property. So here it's additional details and instructions about how the services are to be delivered. Do you need to use a catheter or whatever? So this could be instructions that you are going to give for the order here. Then we also have here something like code. What is the code? So this is in fact a code that is matching the service request. So it's a specific code for this service request. And it means that you can use a code to identify what type of request you have here. Is this a lab order? Is this an imaging order, etc.? You can specify that here in this code. And then we have all kinds of other things that can come up here and that we can fill in. Before we are subject and encounter, those ones are also easier to understand. like instantiates canonical, whatever. So sometimes you have to read carefully what they mean with each element. But as a rule of thumb, the things that I don't understand are probably not important. I start with the things that I understand here.
But it might be that all these fields that we see of service requests are not, how can I say, are not shown, how can I say, in OpenClinic. I mean, if we don't have to insert all these fields.
No. You have to look at the cardinality here. So this is, if you have minimum one, it means that it is mandatory.
Okay.
You see here for the standard, there's very few elements that are mandatory. In fact, you have a status and intent, and that's about it. Of course, that would not be, subject. The patient that it belongs to is also mandatory. But it would not be very helpful, I think, if you only would have that information. Even for the HL7 standard, the identifier is not mandatory. But for the HappyFIR implementation, it is mandatory. Otherwise, the library would not be able to generate these URLs for these unique resources.
Okay.
So sometimes the HappyFIR standard, the HappyFIR library is more severe in terms of mandatory elements than the HL7 FHIR standard itself. Okay. So let's say that we decide to use this service request as a solution for our lab order. It could be also something else. We also have other, like in some implementations, people are using like I think it's Diagnostic Report. So Diagnostic Report is another resource where you can also fill in a lot of stuff, and you can have a look here what it is used for. So this is a report, test, results, labs, laboratory. So this is for representing lab results. In some implementations, I have seen that they are using the same report also for lab orders. They just don't fill in the result values, and they use the same form. So yeah, that's convention. And everywhere there's a standard, there is misuse of the standard. So I don't think you should use, in fact, the diagnosis report for the order, but okay, for the time being, it's just an exercise.
Okay.
So we decide to use this service request. If I would decide to use another class, I could do that. I would have to say here then Diagnostic Report, and then I would use the Diagnostic Report. Oh yeah, in Eclipse, let me just remove some stuff here. Oh yeah, okay. I see that, in fact, in Eclipse, it has been underlined here, it generates an error. And because the resource Diagnostic Report or the class Diagnostic Report is not known yet to my class here. So I will have to import it from the HL7 FHIR R4 model. And if I would click on this one, it would import it, and then I will have a diagnostic report. And of course, then I also have to return a diagnostic report and not a service request. Yeah.
Sure.
And the same below, I would have to change everything here in diagnostic report. My operation will, in fact, return an operation that is, or a resource that is a service request. And I will have to find a lab order in OpenClinic. And to find a lab order in OpenClinic, I will have to use the ID of the lab order. And I will then have to collect the necessary information related to that OpenClinic lab order and put it into a lab request. Sorry, into a service request. Yeah. Mm-hmm. Then we can send the service request back.
Okay.
So how are we going to do this? I will give you an example. In fact, in OpenClinic, maybe I should first explain that. In OpenClinic, we are using what we call the good electronic health records model. And this is basically composed of some very simple principles. It means that a patient has only one unique identifier, of course. A patient can have zero or more health records. Mm-hmm. And in each health record, we can have a set of 0 or more transactions. What is a transaction? A transaction is, in fact, a logical collection of data that go together and that are you can conceive that as a document in a patient file. It could be a lab order form, it could be a lab result form, it could be an imaging order form, it could be the report of a clinical examination, whatever. So these collections of information are called transactions. And a transaction is composed of other transactions, because you can have, for instance, in an outpatient consultation, you could have a clinical examination, you could have some lab tests, you could have some other stuff that are included in there. So a transaction is composed of other transactions or items. And an item is the smallest possible representation that is still meaningful of patient information. For instance, a body weight of 70 kilograms is an item. I cannot split that up in smaller pieces. 70 doesn't mean anything. Kilogram doesn't mean anything. Body weight doesn't mean anything, because if I don't have a figure with it, it doesn't mean anything. Body weight of 70 doesn't mean anything, because I don't know in which unit it has been expressed. So I need the combination of these different attributes to be able to say that it is an item, meaning that it is meaningful information for the patient. And in the OpenClinic database, you will see that reflected in the structure of the database. So if we go here to use OpenClinic DBO, we have a list of health records. So where we see that there's a beginning date, there is an unique identifier of a health record, and it is mapped on a patient ID. Usually in a system, we only have one health record for one person. But if we are talking about more complex settings, you could have different health records for one and the same patient. For instance, if you have 3 hospitals and each hospital has its own OpenClinic system, but they are part of a group, and on the group level, the patient only exists once, has one unique person ID, which could be, for instance, a national identifier, the patient could have different health records in these different sites of the hospital group. And then you would have more than one health record for one person ID. So, and then we have transactions. And these transactions are all linked to a health record ID. Each transaction is linked to a health record ID, has a unique transaction ID, date of creation, whatever, and then a type of transaction. So these are minimal clinical data. So we can have different types of transactions. And in fact, such a transaction type in OpenClinic basically matches a data entry screen. So if I look here at OpenClinic and I open a patient record, like this. So here, this is external consultation or outpatient consultation. This would be typically a transaction. And each of these fields contain meaningful information. There would be items. Yeah. So such a screen is typically a transaction, and I will see that such a transaction also has a transaction type. If I look here in my browser and I move over, I can't see it. Yeah, you can see here underneath the screen, you can see that there is an indicator that type, transaction type equals, and then a whole specification, which is transaction type, Gitega, consultation, whatever. So this is, in fact, each of these documents is linked to a transaction type. And based on the transaction type, OpenClinic will decide which data entry screen has to be opened for that specific transaction, because it only has the transaction ID. It will open it, but using the transaction type, it will decide which data entry screen has to be opened. And I can see that here. It is defined in common XML. And then we have a file there, which is called forwards XML. Yeah. And
how many transaction types do we have?
A lot. 205 here, I think.
Wow. So they differ because they have different entries. So by specifying which type of transaction we have, we can also know which entries we can leave or not.
Yeah, that's true. So here in these forwards table, we will see that, for instance, a transaction type here, assessment, COVID-19 assessment, will be mapped onto this GSP page. And this GSP page will in fact be a viewer, will be a data entry screen for that type of transaction. And that GSP page will search for specific, or will present specific items for that transaction. For each of these transactions, there is a list of items that can be linked to such a transaction. That's basically the data model of OpenClinic. So if I will copy this one, if I want to know which items can be part of such a transaction, I would transaction items where transaction type ID equals. And so this would give me the list. So this is the transaction type. And then I have also a list of items. These are all item types that can be linked to this transaction.
Oh.
And each of these items will have a specific viewer inside the data entry screen. And this viewer is not predefined because you're not always handling things like the heart frequency or the body height or weight in the same way. It depends on the context where you're going to use it. So we did not predefine for each of these item types the viewer that must be used, but the viewer that is going to be used is defined in the GSP page. So in the data entry screen, that's where we find the viewer that is going to be used.
Oh, okay.
All right. And so that viewer, that can be, I don't know, a list box, it can be a select option, it can be a checkbox, a text field, a numeric text field, whatever. So we have a whole list of potential viewers for each of these items. All right. So one of these transaction types is, and I will see where I have it, another one. This is, yeah, this one. Is called lab request. So this is a transaction type lab request, and this is typically a lab order. Yeah.
Okay.
And that lab order will be opened with the screen, data entry screen, manage lab request. So if I would look here at OpenClinic and I see that I do have a lab request here, the system does have the transaction type and the transaction ID. And based on that, if I click on it, it will forward that transaction to this health record manage lab request view GSP that has been defined in the forward XML. Yeah. And the content of that transaction will be viewed with the appropriate viewers. For instance, for clinical information, I will have a text area. And for some other stuff, I have another viewer that is being used.
Okay.
Yeah. So it means that this transaction will have a unique identifier, which is the transaction ID. Yeah. And the unique identifier is, if I look here at these transactions, is in fact a combination of the server ID, because this will define on which hospital server the transaction has been generated, and the transaction ID. So this would be 1.2832. That would be the unique identifier of that transaction. I can have on another server in another hospital, I could also have a transaction ID 2832. But if I want to have these servers being part of the same group, I would have to use another server ID for each of these. And then I have different unique IDs. Yeah. Because this is a counter that is being used on a specific server instance.
Okay.
So I can identify my transaction with by using a simple UID, a unique identifier. Okay, so I go back here to my lab order. And let's see if we can just do something very basic. I could say, I am going to, if someone is requesting my lab order with a specific ID number, I'm going to search if that specific ID number exists. And you have different methods available in OpenClinic to find a transaction, but I will use one here, which is a very basic one, which is med1 query. This is a very generic object, but that lives on the session level. So you only have one med1 query object, not even on the session level, on the application level. So this is a static object that is being used by all sessions on the server. So it's only instantiated once. And then I'm going to get an instance of it. And then I will have to find a specific transaction. And so I can load the transaction and I can use a unique identifier of that transaction. That unique identifier should come here from ID.
What is entered.
Yeah. So I will use that one. I will say here the ID, and then this will be get ID part or something like that. Yeah. I only need the ID part. So that should do. And this would be my transaction. What this is returning is a transaction value object. So I can see that here. Come on. Yeah, so transaction VO, this is a transaction value object. So I can say here, transaction value object, and I call it lab order. Supposing that it is a lab order, and this doesn't exist yet, I will import it from the OpenClinic libraries. So now I would have retrieved the transaction that matches this ID. The transaction which will also contain all the items that are part of that transaction.
Okay, do we need to check if it is a valid ID?
Well, what we will have here, I will see now if this lab order is not equal to null, then it will be valid.
Perfect.
It means that this is a valid, otherwise if it is not valid, I will not have a lab order here that has been
okay.
And I could also even check if it is a lab order or not, but I will not do that because this lab order service or resource provider, maybe afterwards I could also use it for other purposes, maybe for other types of orders, because typically you can only have one resource provider for each type of resource. So if I have different types of service requests, I will have to make sure that I provide functionality here with optional parameters that will enable me to distinguish, for instance, between a lab order or an imaging request or any other kind of a procedure that has been ordered. For the time being, we just leave it like this. So I know that my transaction exists here. And let's say that in that case, I want to create a new service request. I call it, let me change the name here, lab transaction. And I will use lab order here. Lab order is a new service request. And then I will return that lab order. Not very useful at this point in time because it doesn't have any content. So I will have to give it some content. I will say here lab order set ID, for instance, because I need a unique ID. and I will use my unique ID of my transaction. So that would be lab transaction get unique ID. And so I would have put in my resource a unique identifier. Something else that I have to put here is, for instance, the priority. Yeah. And a priority can be set. There's a preset list of values. So we see here service request priority. I could use this service request priority. And I will see that there's different predefined values. I could say here urgent, but I don't know if it is urgent. It has to be based on the content of my lab transaction. Yeah? And as you can see, I can specify here an emergency, normal, routine, or urgent. Yeah.
Okay.
So suppose I say that this is urgent. Yeah. I save it. I can see here in my lab requests that the transaction ID is 66102. It is also specified here, document ID. Yeah. So this is the unique identifier. So if I'm looking here for my transaction, what was it? 66102. I will only have one transaction. Transaction type is lab request. Yeah, so that's fine. And now I can look for the items that are part of that transaction. Okay, and I see that there is a set of items here. And one item ID is here the lab urgency item. Okay. Yeah? And so this has been marked now as urgent. So in that case, I would mark it as also as urgent. Yeah. So okay. I will copy this one and I will say here, if lab transaction, I'm taking my lab transaction, I'm going to get a value of an item, get item value. So I'm looking for the value of the item with this ID. If that equals, we'll use ignore case, urgent, in that case, we will set the priority of the lab order to urgent. Yeah? And else, I would set it, for instance, to, I don't know, routine. So you can already see that we start playing with the OpenClinic object model to translate the OpenClinic content into content for the resource of the HL7 FHIR model here. Yeah.
Okay.
And of course, I could add some other stuff here. So only if we have specified a valid ID, it will return a lab transaction, and it will fill in the ID for that service request for the HL7 source, and it will set the priority. That's not a lot. We will have to add stuff afterwards. But if we have this, it will return that service request. So we can already try to see if this works. Will it work? It will probably not work, because in fact I will execute it and I will see why it will not work. Do you already know why it will not work?
So for the part of the priority, I guess it's fine, because it should not give any problem. I mean, even if it's not correct, but it's not, I guess, essential for. So the problem must be above. So something related to authentication. But I guess that's.
We will see that this new resource provider, lab order resource provider, has not been added yet to my Restful server. So my Restful server has no knowledge of that resource provider. So if I'm going to execute.
Oh yeah, I see, because there was patient and image.
Yeah, and
okay,
the other one was not defined. So if I'm going to do this, and I will, yeah, so this service request, I will ask for it. It will say me, I don't know what that is, service request. I don't know how to handle it. I only know these ones, patient, imaging study, and the other ones are just default resource. So what I will have to do is, here in my Restful server, I will have to add my new lab order resource provider, like this. I think now it should work. So I will save it. I have to wait until Tomcat restarts, or reloads rather. So after making modifications in your Java classes, you have to wait a little bit until your logging says here that the context has been completely loaded again. So, and then you can re-execute. Otherwise you will have a bunch of errors. So if I'm executing the same now, oh, yeah. I'll wait a bit. Yeah, so I get a response now, and the response is a resource type service request with an ID and a priority of urgent. Yeah, so it works, but of course this is very limited for the time being. It is not such a good idea to put all the logic. Where was I? Lab order here. To put all this logic for translating OpenClinic model into the FHIR model, to put it in this resource provider. It's better to put this transformation logic from OpenClinic model to FHIR model, to put it in one of the objects that in OpenClinic that are supposed to handle this kind of stuff. And typically in OpenClinic, an object that is handling lab orders is the object lab request. So I could, in fact, erase all this thing, all this stuff here, and use my class. Well, I will not need this then. I will say return lab requests. And then I can simply ask for a FHIR lab order based on my unique ID for my transaction. So this would be then the ID, get ID part. Yeah. Of course, this is easy if this function already exists and I have I have prepared this because if we had to write it today, it would have taken too much time. But I have put that in this OpenClinic object, which is OpenClinic Medical Lab Request. And I have implemented a method which is called get FHIR lab order. So this is in fact the function that is going to translate my FHIR object, my OpenClinic lab order into a FHIR object. It's only an initial implementation, just for the purpose of showing it. So here I'm going to do the same thing. I'm going to create or to load the transaction. If the transaction is null, then I will also return a null. And so there will be no content returned. Otherwise, I will create a new service request. I'm setting an ID. I'm setting also the status of the order, which is always active. I'm setting the intent, and this is the intent here is an order. It's not a plan or an instruction or whatever. It's an order. Then we can also specify, in fact, the category of a service request, because you can have different service requests, as I already explained. It can be an imaging request, or it could be a surgical intervention request, whatever. But to specify the category, we can use codes. And if we have a look at the FHIR specification, service request, if we look here at category, this is a codable concept, and this is the classification of the service that is requested, and we can use service request category codes. And there's several codes that have been defined, but for instance, if we are using the SNOMED CT classification that you probably already know, you have heard of that?
Yes, yes.
Yeah, okay. Within SNOMED CT, there is a number of codes for different types of procedures. These are just examples, yeah? And this code, SNOMED CT code, would be the code for a laboratory procedure. Yeah. Yes. So I have used, so the coding system is this one for SNOMED CT, and I'm using this code from SNOMED CT, and I'm also setting a display value, which means that it's going to be displayed as laboratory procedure, or I could call it something else here, but this is in fact the label that is being used by SNOMED CT, so I'm going to use the same label. And then we can have some supporting info. This is typically information that would be necessary for the person that has to perform the order. So typically at the laboratory, if they have to do some lab tests, they might want to know what disease the patient is suffering from. So if they have abnormal values, they can easily know that these abnormal values might be compatible with a specific disease, and that they don't have to redo the test again because they have abnormal values. Okay. So what I'm getting here, this is just text. So I'm setting a display value, and I'm getting this from the lab transaction. It's again an item that I'm going to pick, and it is the item which is called item type lab clinical information. If you remember, this is where we did put in our lab order form here, we had some clinical information, and I could say this is some clinical information. If I save this in the database, I will see that for my items, I have an item type lab clinical information, which is containing that type of clinical information. Just a moment, I have to receive a package. 2 seconds. All right. And so I decided to put this information in the supporting info. We will see that in the definition of servlet requests, we have a field which is called here, supporting info. Yeah.
Okay.
And you can have different, so 0 to infinite, any kind of information that you would like. And this is typically used for additional clinical information. Yeah. So this property, supporting info, is implemented by the HappyFIR library using, so you can just add here, ask here for the different methods that exist. And you will see all the body side and any kind of fields that can be set. And you also have setters for reason code and priority, etc. There's all kinds of elements that can be set here. Typically, if you have a maximum of 1 element that can be set, you may have a set operator, a set method for that property. If you can have an unlimited or you can have more than 1 element that can be set, then you will have an add functionality or property. So then I could call this method several times and have different supporting infos registered there. Then we have here the implementation for urgency. I have implemented a priority, the same thing that we've done before, for the different types of priority that exist in OpenClinic. We have 3 types of in OpenClinic, but they match, in fact, essentially on 2 types here in FHIR. Okay. And if it is not specified in OpenClinic, then we also leave it unspecified in the lab order. Okay. And then we have a list of analysis. So because related to a lab transaction, we have analysis that can be ordered. And so we can I can retrieve here a hash table of all the analyses that are linked to a transaction with a class which is called requested lab analysis. And here I can get all the lab analysis for a specific lab request, and where I use the same unique identifier, so the server ID and the transaction ID. And it will return me all the lab analysis that are linked to that transaction. I find the person ID here. Yeah. I'm setting the subject. So based on the person ID, I'm setting the subject, because this is the patient that is linked to that lab order. And this is being done using a reference. A reference is specifying the resource, and then slash, and then we have the resource identifier. So this would be a unique identifier for the patient. And I can also specify, set the display. So this is just a label that will be displayed for human reading, but that is not used for identification, of course. So I will just display the full name of the person with this ID. Okay. The same for an encounter. I will check which is the encounter that matches that lab order. So I get the active encounter on the date that is the same date as the date from the lab transaction. and for this specific patient. So if I get an encounter, means that I have an active encounter, then I will set the encounter, and I'm using the same thing. Say reference, there the HL7 FHIR resource is also called encounter, and I'm using the unique identifier of that encounter. Yeah. Of course, and we will see that in a minute. If I have this reference, my FHIR server would already be able to solve this reference because I already have a resource provider for the resource type patient. It would just use the Restful patient resource provider to retrieve that.
Yes,
but for encounter, it will not have an encounter resource provider available. It means that it will not be able to solve it. It will just be information, but I will have no way of getting that encounter as long as I didn't specify a RESTful encounter resource provider.
Okay. So
and then I can add some other stuff. The specimen, yeah, I already have the encounter. Okay. And then I could add order details. This is one potential implementation. So where I'm creating, in fact, an order detail, and this will contain the details of my lab order. And I will run through the list of analysis that I have found here, linked to my transaction, to my lab order transaction. And for each of these analysis, I will add to my order detail a coding. My coding system will be OpenClinic. I will set the code that has been used for this analysis in OpenClinic. And I will also have a display value, which is in fact the translation for the lab analysis with this specific code into the default language of the system. And if the default language is not specified, it will be in English. Yeah. But if I have a default language, for instance, is in Spanish, then it will show it in Spanish. Yeah. So this is already a little bit more elaborated version of creating a service request of type lab order. I have added a little bit more information. Yeah. I have also added in the order detail codes for the lab analysis, and I will then return that lab order from this method. And it means that I will receive it here from this function get FHIR lab order, and this is then the service request that I will return.
Yes.
Right?
Yes. Just if I can ask the very last part of this function, lab request. I didn't, in the other, didn't really get order detail. The last part, I didn't really get what it is doing.
Okay, so in the order detail, we will have that somewhere here. Yeah. So here you have service request order detail codes. So this is, I can put it here. So these can be all kinds of codes that are specifying what is being specifically ordered, which tests or procedures are being ordered in this service request.
Okay.
It doesn't have to be lab, but it can also be lab. And if it is laboratory information, it would mean that I will have to specify in this order details a list of all the codes of lab analysis that I'm requesting in this service request.
Okay.
So if I want to do a red blood cell count, a white blood cell count, I will want to measure blood sugar, etc. I have to specify a code for each of these tests that have to be performed. Yeah.
Okay.
If I look at OpenClinic here, in my lab requests, I have added 3 types of lab tests. Toxoplasmosis IgM, IgG, and rubella qualitative. Yeah. So these are 3 tests that I'm asking.
Yes.
They have an internal code in OpenClinic 102, 103, and 104. Yeah. And they have some units, etc. But at the lab order level, that's not important. Yeah. So I want to know which codes have been ordered. The results are normally not provided in an order. So, okay, if I have a look now at my code, what I'm going to do, I create an empty order detail. I add an order detail, but by default it's empty. Yeah.
Okay.
And then I have here used a function. I think I can just put it a bit lower because it will make it more easier to read. So that's a more logical link. So here I have, in fact, created a hash table, which is called analysis, and which is retrieving all these lab tests that are linked to my transaction, to my lab transaction here. So I'm specifying the lab transaction get server ID and transaction ID. This is the unique ID of my lab transaction. And I'm requesting all the lab analysis for that lab request. Yeah. And this is sending me back a list of analysis. And each of these analysis is of the type requested lab analysis.
Okay.
It's a hash table, in fact.
Mm-hmm.
So what I'm going to do, I'm going to run through this list of analysis.
Mm-hmm.
I will extract the lab analysis code. This is the 102, 103, 104, etc. Yeah. And I will, for each of these codes, also extract the lab analysis, which contains the units that is going to be used, reference values, and some other stuff. Yeah. And in fact, I'm not using it yet. It's maybe for later use. And then in my order detail, so the empty order detail that I have created, for each of these analyses, I will add a code, set the coding system. In my case, it's not SNOMED CT. I'm using internal OpenClinic codes. And I'm adding also the code. And I'm adding also a display value, because otherwise I will only have OpenClinic 102, and the receiving system may not exactly understand what that code is. So I can also add a text label to it that is going to explain that this is a toxoplasmosis IgM or IgG or whatever. Yeah. This is a function, in fact, where based on the lab analysis, it's not really based on the code, but each of these lab analysis do not only have a code, because the code is not mandatory. You can have a lab analysis without a code, but we are using the ID. There's an ID number for each of the lab analysis, and based on the ID, we can retrieve a label for the lab analysis and translate that label into a specific language. In this case, normally we do that in the user language, but the user language is not being specified here. We could specify that as a parameter, but it has not been done yet. So yeah, maybe that would be a nice exercise to specify that it has to be returned, for instance, in French. And so that will add for each of these analyses inside my order detail, a code and a label for each analysis. Yep.
Okay, I see.
let's have a look at it, how that looks like, because that's quite often that's easier to understand. Okay, I'm asking for my service request. And what do I get? So I get my service request with my SNOMED CT laboratory procedure specification. So that's my category of service request. It has been specified as urgent because I had also marked urgent in my OpenClinic lab order. And then I have my order detail. And for the coding, I get a list of codes for my order detail of stuff that has been requested. Okay. And so these are labels that are coming from the system. Okay. I don't know where the labels are coming from, but well, I would have to look. But so we have, in fact, labels. This looks like short labels that are being entered here. Yeah. And so each time I have specified that the coding system was OpenClinic. The code is 104.3.2. This is the code that is linked to the analysis. And then I have also some text label that explains which analysis this is. For my patient, I had specified a reference and a display value. Yeah. So this is my patient. And I see that this one is underlined because HFIR knows that the servlet or the server can handle patient resources. So I could just easily click on this one and it will just retrieve that patient's resource for me. So this is making it possible to navigate from one object to another. It didn't do the same for Encounter because I don't have an Encounter resource provider and it would not be able to handle that request. So it doesn't transform it in a URL. Okay. And then
so as soon as we create
Encounter, yeah,
we
it
can
will also be underlined, and then we will be able to retrieve also that. Okay.
Yes.
So far, so good. It's a lot of information in very little time, but it's.
Yes, I mean, I follow, I understand, but at the same time, I'm, you know, if I have to do this on my own, I would like, I don't know, I would be like, I don't know which function, which object to use.
Yeah, that's true, and that's a handicap if you don't have the deep knowledge of the domain object model, and as well at the level of the FHIR standard as at the level of OpenClinic, that will take time to figure that out, and that takes weeks or months. But of course, we don't have that, and so that's why I'm going to help you out with a number of these objects. Okay, so with this, a good exercise would be to try to write an Encounter resource provider, and it may not be very easy, but I'm gonna give you a couple of hints. It would be nice if you, based on this part here, and so I'm gonna send you the registration. So I have recorded the recording of this session.
Thank you.
So you can always review it. But it would be nice if you could produce the same resource provider class on your system, and then make it possible to have this one underlined so that we just can click on it and get some content of that Encounter. Okay. The object in OpenClinic is also called Encounter. And what I'm going to help you for a very small part. What we could do is find the Encounter object. And I will go here into, it's an ADT. Now we have Encounter. And I could create here, so this is where you find the encounter in OpenClinic, right? So here you have encounter, and I could create here a function or a method which is called public, and of course it will return an encounter object, but this time it will not be an OpenClinic encounter. We will have to change that afterwards. Oh, sorry, it's static, public static encounter. And the method would be get FHIR encounter. And of course, we would have to use an ID here. And if you can use the same logic as the one that we had here. So we have here get FHIR lab order. We will have to specify a unique ID. So which will be, I could say UID, whatever. So this would be, in fact, the method that would retrieve an encounter. Yeah. And what I'm going to do here is, first I will have to instantiate an encounter. So I will first see if I can find the encounter that is specified by this UID. So my encounter here would be get UID. Yeah. And if the encounter is not null, then I can start filling up the FHIR encounter. Yeah.
Yes.
And otherwise I would here return null. Now this encounter is in fact an OpenClinic encounter. So this is not what I want. I want to return a FHIR encounter.
Yes. Mm-hmm.
So I will have to prefix it with that FHIR stuff here. I can find that in the import. Will be something like this for the model. So if I find, yeah, I have to specify it explicitly because otherwise there will be confusion. So, and the first thing that I will have to do here, if my encounter is not null, I will have to create a new FHIR encounter. So this way I have an empty FHIR encounter.
Yes.
Yeah? And then I have to start filling the FHIR encounter resource.
And then I return it.
And then you will return it.
Oh, so sorry, what is meant for encounter? Because now that doesn't sound familiar to me.
Encounter, it's a contact between the patient and the health facility. It could be an outpatient consultation. It could be a hospital admission. It could be a day clinic event. You have different types of encounters. Typically, an encounter is a consultation or an admission.
Okay.
Yeah. And so now you have this functionality that you would be able to call from an encounter resource provider in a very similar way as the one we had with the lab order here. Yeah. So here I did this. You will have to do the same with the encounter. Yeah.
Yes.
And then we can maybe see tomorrow if you manage to do this. We can then also see if we can figure out how to find encounters.
Okay. Okay. Yeah. So the read part.
Yeah. Well, one part will be to code the same content as the one I have coded here now for the lab order resource provider. And then you will have to create a new encounter resource provider, add it to the Restful server, or the servlet, and then you can start testing it.
Okay, I see.
Okay.
And for the reference page of the encounter in FHIR is called encounter.
Yeah. It's called the same name. So if you would use here, oh, sorry, it's not there. So I would just use here encounter. I think you would have it. Yeah. Resource encounter, and then you will have the content of an encounter. Yeah.
Oh.
Not everything is mandatory, of course, and you could just also, as a starter, fill in 1 or 2 or 3 fields, and then you can just already test what it does. There's no point in filling up the whole encounter and then afterward seeing that you started with on the wrong foot and you have to start over everything again. Just start with a couple of properties and then test it with those ones.
Okay. I will also need to add encounter resource to I don't remember the name of the page, but along with patient, image, and lab order.
That's the RESTful servlet. Yeah, you will have to add it there. Yeah, so that's true. So if you look here at the RESTful servlets, this one, yeah, here.
Yes. Okay.
That's where you will have to add it. Okay.
Okay.
Okay, then I would say I wish you good luck with this. I will convert the recording in something viewable. I will put it on YouTube, and then you can download from there. And it's also going to be useful for other people, I think.
All right. Thank you so much.
Okay, you're welcome. Bye-bye.
So I guess we will talk each other
tomorrow.
Okay.
Tomorrow at 10 o'clock.
Okay. All right.
It will be a shorter session then. We will build up from these ones, but this was the introduction, and so of course it always takes a couple of hours. It's normal.
All right. Okay. Thank you.
Okay. Bye-bye.